The first thing I want you to do is pause this video and see how many of the different measures of spread and center you already know and can figure out from this graph. Press play when you're ready to go to the next screen. So in this data set, I have 26 data points. So if I want to find the average, I'm going to do 4 times the value of 0, 4 dots of 0. Then I have 5 dots that are 1 plus 8 dots that are a value 2 plus 4 dots of value 3 plus 2 dots of value 4 plus 1 of 5 plus 1 8 and 1 10. I'm going to divide all of that by the 26 points, and I get that my mean is 2.46. Obviously, I could have taken a lot longer and done all of that separately, but even with condensing it down, it's still pretty tiny, pretty long. So now let's look at the median. If I have a total of 26 data points, that means my median is where I have 13 to the left, 13 to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my median is definitely 2. My mode is also 2. My minimum value is 0. My maximum value is 10. So that's where we get our min, our max. So quartile 1, if I have 26 data points, your quartile 1 is going to be the midway point between your min and your median, which in this case would be 1. And your quartile 3 is going to be the midway point between your max and your median. So that's going to be 3. So to find my range, remember that's max minus min, so 10 minus 0 would be 10. And then IQR is Q3, which we found is 3, minus Q1, which is 1. Now, 26 data points, that's not too many, and these are all fairly clustered values. You know, we don't have anything too spread out or decimals, but even doing that part by hand was still a little bit tedious. So wouldn't it be great if our calculator could do this stuff for us? Dun da da da! Calculator instructions. So, what we want to do is we're going to press Stat, Edit, and plug the numbers in. So that's what we do to enter data. If you want to clear a previous list of data, which you'll have to do a lot during the AP exam, you need to arrow to the top so that you're highlighting L1 or highlighting L2 and press Clear, Enter. Never, ever, 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 ever press Delete. Don't press Delete. So you'll see a list like this, and then when I want to calculate stuff, this is kind of where we start everything for stats, is entering our data into a list. And what we're focusing on now is stat calc, and the first thing that pops up is 1 var stats. That stands for 1 variable stats. Because what are we doing right now? 1 variable statistics. When you do that and go through clicking that, you're going to get 2 screens. One you have to kind of scroll down on right here. What we're going to use is this first thing that shows up. We read it as X bar, and that is my mean of my sample. Then we're going to use SX as our standard deviation. N gives you the sample size, so that way I don't have to count up the fact that I just had 26 data points. And then we call the second screen our 5-number summary, and that gives me my min and my max, and my quartiles and my median. So we keep using this word standard deviation, but what does standard deviation tells us? It tells us the typical distance each value is from the mean. And generally what it means is if I have a big standard deviation, then that means on average my data is farther from the mean than a smaller standard deviation, which means I don't have too much variation on average. a lot of the data points are closer to the mean. If I have a 0 standard deviation, that means all the data points are exactly the same. So we're going to learn how to calculate the standard deviation. The first thing you need to do is find the mean. So we're starting with a really simple little data set right here, 1, 2, 3, 4, 5. So my mean is 3. The first step of calculating standard deviation is to calculate deviations from the mean. That means I'm going to start with the 1 and then I'm going to minus the 3. So that would give me -2. Then I'm going to go to 2. 2 minus my mean of 3 would be -1. My next value is 3 minus my mean of 3. Do you get the idea? We subtract those values. Okay, so then I'll have 4 minus 1 is 1, and 4 minus 3 is 1, 5 minus 3 is 2. Okay, so those are called my deviations from the mean. -2, -1, 0, 1, and 2. Next, what we do is square those deviations. So -2 squared would be 4, -1 squared would be 1, 0 squared would be 0, 1 squared would be 1, 2 squared would be 4. Now, it says find the average, kind of. So what we want to do is we're going to add those together. 4 plus 1 plus 0 plus 1 plus 4. And usually to do the average, I would divide by the number of things, aka n. What it means by kind of is when I'm finding standard deviation, we actually do your sample size minus 1. Okay, so it's not actually the average. We're doing subtract 1 from the denominator. This has to do with something called degrees of freedom, which is probably more in depth than we actually need to talk about. But there is a mathematical reason that it's n minus 1. All right, so that gives me 10 over 5, which would be 2. And then unsquare, what does that mean? We're going to do the square root, which is about 1.41 blah blah. Here's what the big scary formula looks like. All right, this just says right here, the last line is what we just did. So S squared is called variance, and I'm just going to pick apart these little pieces, and standard deviation is the square root of variances. So remember, X bar, that's my mean, okay, and so the inside part, that's where we found the deviations from the mean. And we did that again by taking the data point minus the mean. So this is deviations from the mean. And once again, that comes from taking your data point, which is represented by X in my formula, minus my mean. Then we squared it. And those of you who have done any calculus have seen this sigma, which means sum, so we added those together, and then we divided by n minus 1. So that is what, when we look at your formula sheet for the AP Stats exam and you see this big scary thing for standard deviation, that's what it is. So what does it really mean? Let's look at it graphically. So I want you to take a second and create dot plots for these 3 graphs. So the first one, I have exactly the same data points. I think I ran out of room. Pretend there's another one right there. All right, then I have 2, 3, 3, 4, 5, 5, 7. I do really great dots with my stylus here. All right. So one of these data sets has a standard deviation of 0. Well, hopefully that's fairly obvious to you. So I'm going to write Sx equals 0 because there's no deviations. Everything is a 4. Then we have two different deviations. We have a 1.7 and a 2.5. So I want to look at my distributions and see which of them seems to be more spread out. So I would say that C is more spread out, so that's going to have a standard deviation of 2.5, while the ones for B are a little more clustered, so that's going to be about 1.7. So we talked briefly about skewedness, and skewedness has effects on center and spread and which one I should be using. So the ones that I'm going to use depends on the shape of my graph. A statistical measure is resistant if it isn't sensitive to extreme values. So think of it as if you are resistant to a new idea, you are not going to be easily moved. Versus if you're non-resistant, you'll go with the flow and go wherever you are being pulled. So in a symmetric distribution, the mean is approximately equal to the median. If it's skewed left, then that means the mean is pulled in the direction of the tail. The mean is less than the median. And vice versa, if it's skewed right, then the mean is greater than the median. So when it's symmetric, we want to use mean and standard deviation. But if it's skewed, we want to use the median and IQR. And that's because the median and IQR are resistant to outliers. They are not substantially affected. They'll be a little bit affected, but they aren't going to be as substantially as affected as mean and standard deviation. So for example, we have a histogram of budgets of millions of dollars of major releases of movies in 2005. So think about ways we've talked about describing your socks distribution, and sometimes for me it helps me kind of draw a little mound. So when I draw this little mound, I look and I notice, to me, it seems skewed right. So since it's skewed, we want to use the median and IQR. And since it's skewed right, that means that my mean is to the right, which means it's greater than my median. And let's read part B. An industry publication reports that the average movie costs $85 million to make, but a watchdog group concerned with rising ticket prices says that the average cost is $46.8 million. What statistic, measure of center, do you think each group is using? So this is where it's going to be helpful that I already thought about mean being greater than the median. So which of these is bigger? The 46.8 million. So the watchdog group is using the mean because they're using the larger number. And then your industry publication is using the median, the lower value. So a lot of times people choose a measure of center to report based on what their goal really is of, their headline and their more particular goal in mind, and not necessarily from a mathematical reason.